Hi guys, my name is Lee Benson. In this video we're going to be exploring how to set up a GraphQL server through Node that's backed by a database. Now for those that don't know, GraphQL is sort of a modern take on how to build an API server. It's a spec and a query language written by Facebook. It's been used in production since about 2012, but it's recently been open sourced. And essentially what it allows you to do is move beyond the idea of REST endpoints. So let's take a typical application, let's say a blog, that may have two endpoints. It may have a list of authors and it may have a list of posts. Now how that would typically work is that you would first query the list of authors to download a list. Maybe each author has an ID associated with it. And then what you would do is you would issue a separate request to the posts endpoint along with the author ID to download their posts. Now the problem with that paradigm is that that could be 20 or 30 different requests for just a handful of different authors and posts. What GraphQL does, in contrast, is it allows you to bundle up all of your data requirements into just one request that's served by one endpoint. And the cool thing about this is GraphQL will respond back with just the data that's been requested by the client. So it's a very efficient and also quite natural way to think and design for an API server. Now with it recently being open sourced, as you can imagine, some of the documentation is quite sparse and the tooling around it is a little bit immature, so it's difficult to know exactly what to use and how to get started. So what we're going to do in this video is go through it line by line. I'm going to show you how to build a GraphQL server in Node, but I'm also going to show you how to use a database to pull information from, because a lot of the issues with some of the example code and the tutorials that I've seen so far is that they're pulling from an array or a data source that typically you're not going to use in a real-world application. So let's instead use a database. Now before I get into this, first couple of things you might want to install if you want to follow along. First thing is a text editor. I'm using Atom, which is pretty nice. It provides all the ES 2015 linting. I'm going to be using that language spec to write this JavaScript code. I've also got Node 5 installed, which natively supports ES6 or ES 2015 as it's now known, with a few exceptions, and those exceptions will be transpiled down from Babel. So we're going to install Babel first of all. And my database store of choice in this tutorial is Postgres, but feel free to follow along. You can use exactly the same syntax with MySQL or other database engines, and the reason for that is because we're going to be using SQLized.js, which is an object relational mapper on top of the database. So let's get started. The first thing I'm going to do is open a terminal window, and I'm going to run npm init, which is going to initialize a package.json file and allow us to add in a whole bunch of npm packages on top. I'm just going to accept all of the defaults, and the first package I'm going to install is going to be something called Babel preset Node 5. Now this is just a little preset that I built that just polyfills all of the ES 2015 features that Node 5 lacks, which are only a few. There's just a couple of things that are missing, things like REST and spread operators, which we may use throughout the tutorial, we may not. But just in case, let's go ahead and set that up. And by the way, I'm using Babel 6, which at the time of recording is the latest version. I'm now going to create a Babel RC file. So every time I run Babel in this project folder, it's first going to look at Babel RC and pull the settings from there. I'm just going to create a preset, and I'm going to tell it that we need Node 5. So that's going to polyfill everything that we need. So the next thing I'm going to do is going to wire up a simple database. Now again, I'm using Postgres, and you can use a tool like pgadmin to go in and use a GUI and create a new database. For the sake of this video, I'm going to assume that we've got a database already, and the name of that database is Relay. And the reason it's called Relay is actually because in a future video I'm intending to target the Relay framework and sort of evolve the GraphQL server to work with that. We're not going to be touching that in this video, but we'll go ahead and start putting some boilerplate against that so we can sort of use it as a springboard in future. So, new file, I'm going to call this one db.js. Of course you can call it whatever you want, and what I'm going to do first and foremost is import SQLize, which is the object relational mapper. And as I add packages to these various different JS files, I'm also going to install them with npm. Rather than sort of batch them all at once, we'll do it as we go along so we can see how these pieces are being pieced together. And along with Sequelize, actually, we're going to need a couple of database drivers. That's because Sequelize doesn't come bundled with the drivers. So we're going to ask for PG, which is the Postgres driver, and PG-HStore, which is the HStore key value database engine, which it also requires. Even though we're not going to directly use that in this particular tutorial, it is something that Sequelize requires. So next step, I'm going to need to define a connection. So what I'm going to do is I'm going to create a constant called con for connection, and this is just going to be a new Sequelize instance. And there's a few options to pass. The first is the name of the database, as mentioned, that's relay. The username is going to be Postgres, and the password is also going to be Postgres. And these are just sort of defaults that come bundled with Postgres. Obviously change these as it pertains to your environment. I've got to also select the dialect, so I've got to say that it's Postgres. If you're using MySQL, you'd write MySQL at this point. And the host is just pulling from localhost. So it's a very simple configuration. If you're running this in Docker, let's say, then of course you could put the environment variables there that are going to point to any particular Docker host or whatever else you were doing. So we've got a connection. The next thing we need to do is actually define the tables. Now, for the purpose of this tutorial, going back to that REST example that I gave you where we've got sort of people and posts associated with them, let's create that same relationship in the database. So I'm going to create a constant called person, and I'm going to use our connection object to define exactly what a person is. So a person is going to be made up of a few fields. The first thing is going to be a first name. And we have to specify a type, which is just going to be a simple string. And I'm going to say allow null is false, because we want to make sure that we're getting all the data that we need to make up a full person. And the same thing is just going to be type allow a Sequelize string and allow null of false. And this time we're going to do it in email, and that too is a string. Allow null is going to be false. This time let's just throw in a validate function as well, which is a Sequelize specific check to make sure that this is an email address. It comes with a whole bunch of different validators. Of course you can write your own, but let's just use this one built in. So that's great, we've got a person now, and now let's create a post. So of course these are defining tables within Postgres. And the nice thing about Sequelize, as with any object relational mapper, is that we're never dropping down to SQL code in this tutorial. So we're not going to be issuing select statements and inserts and things like that manually. Instead, we're going to just simply through JavaScript define how the data should be laid out and how to query against it. So this time it's going to be a post. And we've got a couple of simple fields here. We're going to have title, which also, my caller example so far, is going to be a string. Allow null is going to be false. And content, this is sort of the main body of the article, if you like. It's going to be a string, and the same thing. So we've got two different tables, but at the moment they don't know of each other. So the next thing we need to do is we need to set up a relationship between the two of them. In Sequelize, it's pretty simple. So set up relationships. And I'm just going to say that a person has many posts. So now Sequelize knows that it has many posts, and a post, in turn, the other way around, so we've got one direction of the relationship, let's go the other way, belongs to person. Okay, so with these two lines, we have our relationships defined. So now we've got these two definitions in Sequelize. What we have to do now is sync that with the database. We actually have to open a connection to the database and tell Postgres that we want these tables to be installed. And what I'm going to do is every time we run this application, it's basically going to reinitialize the tables, and I probably want a few different fixtures in there as well, just some fake users to feed this database, just to seed it a little bit. So I'm going to go to connection, open the connection. There's a function on that called sync. So that's basically going to synchronize our definitions, and I'm going to pass it the parameter force. And the reason for that is every time we run this, it's going to check whether these tables already exist, and if they do, and it tries to overwrite them, it's going to complain, whereas force just overrides that. So that's fine. And this is a promise, so we can then say then. So once it's done that, once it's installed the tables, let's go ahead and actually add some fixtures. Now what I'm going to use here is the Lodash utility belt, because there's a convenient function there called times that allows us to repeat a function a certain number of times. So let's first go back to the top and let's import Lodash. And of course, I need to follow that up with an npm installation statement. And here what I'm going to say is, let's say we're going to run this thing 10 times. So in other words, we're going to have 10 new users added. And all I'm going to do here is return a promise. And that promise is going to reference the person table that we've created. And it's going to say person.create. And then we just pass in the name of the columns. So in this case, first name. Now rather than just type in some static data at this point, what I'd like to do is import another package called Faker. And what Faker allows us to do is just randomly generate a whole bunch of names and email addresses and demographic data. So I'm going to import Faker. And once again, npm install that. And down here, we can reference faker.name.firstname. And last name follows the same format. And email is almost the same. This time we're pulling from the internet source. That's things like IP addresses and things like that. I'm going to grab the email from there. So if we were to run this thing, first let's just export it. Export the connection. So this is going to be used as a sort of a module. We're going to import this into our GraphQL schema in just a moment, but this also works as a standalone application also. So if I was to do Babel node db and just run the thing, you can see a whole bunch of fixtures there, and if we actually look at some of this data, of names and email addresses and things like that. We could also open at this point a separate window and let's run PSQL, which is Postgres is command line utility, and I'm just going to log in with the regular credentials. And if you run a schema dump, you can see that we've got a people table, and we can select star from people, and we should have the 10 people that we've added. Perfect, we do, and we've got all the information there. Now let's also add some posts, because if you remember, we have a posts table too, with title and content, and you can see also we've got a person ID integer column which references the person table. So we can very easily do that in SQLize just by adding on to this promise. So we've created the person. At this point we can also say then, once we have the person, let's do something with them. So we've got a person object, this has been loaded and inserted at this point. So what we'll say is we'll return person.create post. Simple as that. And title, we'll say sample title by, and let's feed in the person's first name, let's say. And content could just be, this is a sample article, let's say. Great, so let's try rerunning this. And this time you can see not only do we have people, but we've also got associated posts along with names and titles and things like that. Okay, so we've got a very basic, at this point, very basic relational database. So now let's go ahead and set up the GraphQL schema, which sort of is a layer on top of this. So we've got our DB models, and now we just need to build on top. So what we're going to do is going to create a new file, and I'm going to call that schema.js. And what we're going to do in here is use an npm package called GraphQL. And what GraphQL is really just tooling to be able to use the GraphQL spec and then further import that into a GraphQL server. So we're going to be doing both of those things in just a moment. First thing, let's import GraphQL from GraphQL. And of course I need to follow that up with an npm install. Now, GraphQL works standalone, but actually we're going to be using some concepts in a moment which are using React and the React DOM, and that's going to be built into our GraphQL server. So at this point I'll go ahead and install those in anticipation of needing them. And what I'm also going to do is import just the DB schema that we've just created, because we're going to use that at this point. So the next stage is just to emulate what we've already done, sort of overlay, if you like, our post and our person schema. So GraphQL has its own definitions. It has its own string types, its own integer types, its own Scala values, and so they're very similar to SQLize's values. Like here we had a SQLize string. Well, when we're defining GraphQL types, we're using similar values, but it has its own built-in types. So we're going to be using those instead. So let's first go ahead and emulate the creation of the person type. And I say emulate because it sort of very closely follows SQLize's schema, but really it's just a layer on top that's going to use SQLize below it. You'll see what I mean in just a second. So what we're doing at this point is we have to define that this is an object type. In other words, it's sort of like a table. So we're going to use GraphQL object type. Where do we get this from? What is this? Well, this is actually just a function that we can grab from GraphQL. So I'm going to open up a pair of curly braces there, and I'm going to start a list of things. As we go along, I'm going to start to add to this list of different object types and different string types that we need as we go along. So this is just a function. So as part of that function, we're going to pass in an object of options, and here we're really just defining a whole bunch of parameters and field types. So here I'm going to say that this is a person. I'm going to give it a quick description just so that our linting, which you'll see in a few moments as we spawn the GraphQL server, knows exactly what this is and can provide descriptive messages. So I'm going to say this represents a person. Real simple. Now we create a fields function, and this is going to be a function, so let me just use the fat arrow function there, and this is going to return an object full of field types. And again, this is overlaying the SQLize equivalent, so basically I'm just going to pass in all of the same functions that SQLize will be returning. So things like ID, in this case it's going to be type of GraphQL integer. We're telling GraphQL that it's just a number, and I'm going to grab this up here so we've got access to that. And then there's this function called resolve, and resolve is what is invoked so that GraphQL knows how to get the data. So it doesn't natively know to pull it from SQLize, just as it wouldn't natively know to pull it from an array or a promise or anything else. So you've got to tell it how to do that, and that's where resolve comes in. Now at this point, resolve has our person object. And the reason it has our person object is because later when we define the query, what we've done once we've found the person is returned the SQLize person object. This is actually found from the database. So at this point, when we're resolving, we can actually just pass back person.id because this is going to come from SQLize. So each of these fields has a resolve function. It's real simple. So at this point, what I'm going to do is now define another field, which is going to be first name. The type this time, if you recall, was a string. So rather than an integer, it's a string. So I'm going to grab that type up there. And I'm going to do the same thing. I'm going to resolve person, and I'm going to return person.firstname. And you can see there's a common theme emerging with these field definitions. They're pretty much all identical. So what I'm going to do is just copy and paste this last one, which is going to be last name. And actually, we're missing one. We're missing email, so I'm going to grab that now also. Just format this nicely so you can see how that aligns. And this one is email. Perfect. So we have our person. Now actually we need to go and define the post type. So let me below that just type const post, much the same way that we did before. And this also is going to be a GraphQL object type. And this one's going to be named post. Simple description. and this is a function, so we feed that in. I'm going to return the fields that pertain to post. Well, we've already got an ID field up here, and because this works exactly the same way, we may as well just copy and paste that. Just format that a little better. And we also had title, and again this uses the same stuff, so let's just grab this. This time, instead of person, it's going to be a post, and we're going to reference the title on that, and the same thing with content. Cool, so we've got our two types. Now what we want to do is we want to create a query type. So we've got our two individual types, but we need to create what's called a root query, which is going to be the starting point for where GraphQL looks to establish the shape of the data that it's returning. And that'll make sense in just a moment. So what we're going to do is create a constant called query. And you can call this whatever you like. These are just convenient names. And this is going to be GraphQL object type again. Name of query, description, this is a root query, fields. So what fields is this one returning? Well, these, if you like, are our public API methods, so we can call these whatever we like. In this case, I'm going to call this one people, because we're going to ask for people and we're going to get people back from the person table above. So let's go ahead and define that. Type, this time, because people is going to return multiple records, potentially, we define something called a GraphQL list. So we say new GraphQL list, and we feed in person. So we're going to say basically it's an array of person, a people array if you like. So we're going to need to grab this from somewhere. We don't have that at the moment, so that also comes from the GraphQL library. Scroll back down to where we were. And this time, I'm going to resolve that. I'm going to say this is called root. Because this is our root query, I could write something else in here like people or something like that, but I'll just say it's our root query by convention. And I'm also going to pass in this second line, which is args. Now, arguments are essentially variables that can be fed along with the GraphQL query that allows you to do something with it. So, for example, if you want to search for people based on an email address or something like that, you've got that list of arguments that you can use to execute against your database. So in this case, what I'm going to say from this resolve method, because this is our root query, it doesn't yet know that this relates in any way back to our database. So let's tell it to return from our database. Now remember, right at the top, we've imported our DB, so basically everything that we've exported here, we're now importing here. And what we're doing down here is we're going to return db.models, which is created automatically for us by SQLize, and we're pulling from the person table, which has been defined, and we're going to say find all where args. Now why does that work? Well, it works for two reasons. First of all, again, args is going to be filled in for us, so if we're searching, for example, for an email address or an ID or something like that, then we're able to, because they reference particular columns within the SQLize database structure, it's going to be able to find those and pull them back. But it's also working because what this is returning is a promise. SQLize uses promises to return results when it has them, and GraphQL can natively use promises. So it provides, as you can see, a very clean way of thinking about how your API server is structured. Now, one of the questions you might have at this point is, well, if you can feed in any arguments, isn't this a security issue with the database? Because at this point, you could imagine if you could just feed in, let's say, any particular attribute or column within the table that you wanted to keep secret, you might not want to expose publicly. And at this point, any argument could be fed in. Well, actually, that's not the case. And the reason for that is because we can specify args, and this allows us to limit the arguments to a particular set of fields. So we can almost sanitize them at this point. So what I'm going to say is we're going to search for people based on ID. And again, just so it knows that this is going to be a GraphQL integer type. So this is always going to be a number. And let's also enable us to search for email addresses. That seems to be an obvious need for an API to be able to search for a person based on an email address. And we can really expand this out in any way that we want. So we could add first name, last name, we could have a regular expression, things like that. But in this case, this is just going to be a GraphQL string, and it's an email address. So now args, regardless of what we feed it, will only ever contain at most an ID and an email address. So that's pretty cool. Let's go ahead now and wire that all up and start a GraphQL server so we can actually start throwing some queries at it and see the sort of shape of the data and how it's returned. So our final step is to create a schema, and this introduces a new type called a GraphQL schema. And the query is just a key on the options object that we feed in. We're going to pass in the query that we've just defined above. So this provides a starting point now for our server. And there's only one of these. So a common question with GraphQL is, can I have lots of different query types and string them together and all that kind of stuff? The answer is no. You have one root query, and that provides all of the public APIs that you would query against. And that will make sense as you start to see how this data is typically structured. Now let me export this now to schema. So we should have everything we need at this point in order to find people. So final step is to create a new file, and let's call this one server. And basically what we're doing now is we're grabbing the schema. We've got the schema ready to find, but we need to put it somewhere. We need to use it in some way. So what I'm going to do is first create a very basic Express-based server that's going to allow us to send HTTP requests to our GraphQL endpoint. So I'm going to import Express from Express, and I'm also going to import something that I'm going to call a graph HTTP, and it's really just Express middleware. It gets a GraphQL endpoint spawned very quickly. And I'm also going to import our schema from the schema file that we've just created. So you can see there's a couple of things there that we need to install through npm. So we've got Express and Express GraphQL. And there may be some peer dependencies for these particular packages. We've come up with no warnings, so we're okay. But if there is, then also, of course, you've got to install that stuff. I think it would warn at that point that React and React DOM wasn't installed, for example, if you didn't have those. Now what we're going to do is create simple config. So we're just going to say that the application itself is going to run on port 3000, just a common sort of local host development environment port. And what I want to do here is actually spawn the application. So let's spawn Express. We've got an instance of Express now. And we're going to say app use on the GraphQL root. So basically whenever we go to /GraphQL on localhost port 3000, then we want to run the GraphQL middleware. So I'm just going to reference the graph HTTP object that we've created above, which comes from Express GraphQL. And we initialize that by opening that up and sending in an object of options. And we need to tell it the schema, which we've exported from here, or rather imported. And we also want to pretty print any GraphQL back. Now typically GraphQL obviously would be quite minified when you send that response back to a production client. But in this case we actually want this to be human readable, so we'll keep it at that for now. Now the final option is something called GraphiQL. Now GraphiQL is this awesome IDE that allows you to query GraphQL in a very nice way and see the response back, and also look through the documentation or the linting of the GraphQL structure, and it provides a nice in-browser interface to do that. So it's a good way to sort of visualize how data is formed. So I'm going to say true. This is going to be a peer dependency actually, so let's go ahead and install that. It's a separate package on npm. Cool, so we've got our application endpoint. I think at this point we really just need to spawn a server. So I'm going to listen on the application port we've created above, which is port 3000. And when that's running, I'm just going to log back to the console and say that it's running. So I'm going to say app listening on port, which is just going to tell us that the thing ran properly. So if all's good, we should be able to run this server. Okay, we've got a problem. So basically I just missed a comma there from the schema.js file. So line 23, you can see I forgot to add the comma. Okay, we've got another one. And because we copied and pasted a whole bunch of stuff, I imagine that same error has been propagated down. And of course it has. 35. And 56. We're getting towards the bottom now, so we should nearly be done. A quick scan of all the other fields just to make sure. Okay. GraphQL schema is not defined. Okay, that's not a problem. I actually forgot to put that in our list at the top. So we just work through these errors. Finally, we're up and running with a server. Cool. So let's see what that looks like. So let's go to localhost, port 3000, and if you recall, GraphQL endpoints /GraphQL, and we've given this nice interface. Now at this point, you can actually just start writing the GraphQL, but rather than do that, let's click Docs, and you can see the root type is query, and when we click through to that, we get this people field that shows us that we can search both on ID and on email address. So that's pretty cool. We've already got some documentation without writing any. And if we click through to person, we can see the fields that person can return. Now to actually write a query in GraphQL is very, very simple. In this case, I could just type people, and I could hit play, and it will fill in by default the ID field. So you can see we've got all 1 through 10 of our ID fields. And if we want to pull in both the first name and last name and also the email address, we can just go ahead and add those and hit play. And voila, we've got all access to all of our database data. So that was pretty cool. That wasn't too hard to wire up. Let's go a step further and let's add a second field query there. So we've got people. Let's also add posts so we can also grab the posts. So I'm just going to exit from this application. I'm going to go back to our schema, and you'll note we already have posts, so it isn't too much more to add this. Instead of people, or just having people, let's also now have posts. So I'm going to say posts, and type, that's going to be a new GraphQL list of posts. So it's pretty much exactly the same as above. And we're going to resolve that by having root and args exactly the same. This time we're going to do db models post, find all where args. I'm going to respawn the server, and we can now type posts, and let's get title and content, and there we go, we've got all of the posts. So at the moment we've got two independent query fields. Let's now add the two together, because you remember right at the start I said the benefit to GraphQL is that you don't need to have distinct endpoints. You can provide whatever shape of data makes sense to your API request and have GraphQL return with that very specific data type. So because we have a person already, let's then find the posts that relate to that particular person. How would we do that? Well, this is how we do it. I'm going to go back to Atom, get out of this, and this time I'm going to go back to my person object, and I'm going to create a new field on person. So we've got our first name, last name, and our email address. Let's also add posts, and this is going to be of type post, and we're going to resolve by having person. In the same way, it's fed the same object as all of the above fields. But this time we're going to return person.getPosts, which is provided to us by SQLize because, if you recall, back in our database, we told it how the two tables were related. So it provides us with these dynamic functions that we can call, and getPost is now one of them, to retrieve the posts for that individual person. So I'm going to respawn the server, and I'll just refresh this so it's aware of the new changes. And this time I'm going to say people, and I'm going to get first name and let's say email. But now let's also get posts, and let's also get title and content. And if I hit play this time, you see that it's returning the names, and it should at this point return title and content. Why has it not done that? Well, let's go ahead and investigate. is because we need to actually define this as an array, because of course we're going to be returning more than one post. So let's go ahead and set GraphQL list again. It's going to tell it this list of posts, and respawn a server, hit refresh, and this time we have the name, the email, and all of the posts. And what's cool about this is we can do this in either direction. So we can go back to our atom, and this time in the post schema, let's define something called person. And this time it's going to return a person, and the resolve function is still going to get post just like all of the other fields, but we're going to return post.getPerson, which is going to return all of the field types from above. So if we hit refresh, I'm going to refresh this so it knows the new definitions, and this time I'm going to do posts, and I'm just going to return title, but I can now also return person. And if you see first name and email, you see not only we have the title, but we also can now find the person associated with that particular post along with any information. And we could do that all day long. We could say posts, title, person, and then within person we could also get posts, and this time let's get the content, let's say, and hit play. And it's going to find us any shape data that we require. So as you can see already, GraphQL is very flexible, and just by defining the field types and the resolve function on how we're going to get access to that data, we can return any data specification back. And so because of that, we only need a single endpoint rather than a static REST endpoint that's there to serve a rigid data structure. Now I'm going to show you one final concept through GraphQL before we wrap up, and that is something called a mutation. So far we've been reading from the database, but let's write something to it. And that's what a mutation is. You can think of it as a HTTP post to a REST endpoint. We're going to put something in the database, then we're going to return the fields that we've put in there. So how do we do that? Well, we first create a new constant called mutation, and we're going to specify that that's a new GraphQL object type. And this is going to follow exactly the same format as all of the other object types that we've defined so far. So we're just going to call this a mutation. And these are arbitrary names, so feel free to give them a name and description that makes sense to your environment, because part of the GraphQL spec is the ability to query what the field is for and to receive definitions back, which is what the graphical interface that we have through here actually does when we click on docs. So let's go back and just say functions to create stuff, and we'll create something called fields, and this, like above, is just a function. So we're going to return a function called add person, and the type of that is just going to be person, because actually what we're doing is we're adding the person to the database, but then we're retrieving that same person through exactly the same format as already defined above here. So we'll also specify some arguments, and the arguments are what we're going to use to feed in to the write request. So what do we want? Well, we want a first name, and we're going to specify that the type of that is a GraphQL string. And a new type that I'm going to introduce now is something called a GraphQL non-null. And essentially that tells GraphQL that this argument is not optional. We have to specify this. It cannot be a null value. So we're going to say new GraphQL non-null. And we also grab that from the GraphQL library, so we'll put that in our list at the top. We'll also throw in a last name, and because these follow the exact same format, we're going to just grab this from above, and the same with email. All of these are non-null fields, they are not optional. Then we're going to have a resolve function as above, and we're going to call this root again, and args. We're not actually going to use the root function here, so in fact let's just put an underscore there just to denote that this is not being used. And I'm going to return db.models.person.create, and remember from the resolve function we can return a promise, which is then going to return the data that we've inserted into the database. So that's great because that data type works exactly with our person type to be able to return the fields from that. And here we're going to feed in what is being created, which of course is the first name. And this is going to come from this, which is going to be the arguments that fed into the right request. So we'll just say first name, last name is going to follow the same format. An email address, well, that's typically a lowercase string, so we're going to just have access to the two lowercase string method there. And then finally, we just need to add this to our schema. So we've got query, now we just set mutation, and I'll insert it above. And just like our query type, if we want to add any more methods, we can do so by simply adding to this object that's returned back. So again, think of it as your public API. This is what your client has access to. And of course in the resolve method, you're able to defend against queries which are non-authorized. So for example, in the resolve method, perhaps there's something here whereby we're only allowed to add a person if we're a certain user, maybe an admin user or something like that. You can throw an error from within the resolve method if that's something that's not authorized. So each stage of the way you're able to check that the GraphQL client is able to perform this invocation. Okay, so I'm going to save that and I'm going to rerun the server. That looks to be working fine. I'll hit refresh so we know what's going on. And I go to docs and you can see we've got two root types now. We've got query and mutation. If we click mutation, we've got add person, and we have a list of the data types that it expects to receive, and it's telling us that it's returning a person back. So that should now work. Now the way that we define a mutation query is just to prefix it with the word mutation, and we can call it something here. We'll just say add person because that's what we're doing. This really can be any label that matters to the client, so that we know exactly on what query this was performed. And we'll also invoke the add person function, and this time we're going to pass in a first name. I'll just do my details. And then we also specify what we want to return. In this case, I'm just going to return an ID because we're going to be able to then check against the database to make sure that this person was indeed added. So I'm going to hit play, and we've got an ID there of 11 with those details. So let's check in the database that that was added successfully. So we're going to go back to Atom, and I'm going to use my second window where I have PSQL open as a window into my PostgreSQL database, and I'm going to select from the person table where ID equals 11, and in fact it's called people because SQLize automatically pluralizes that for us, and there we go, ID, name and email address. And you can see that the resolve function is working correctly. It's lowercase and everything. If I was to, for example, go and add a new email there, let's capitalize that just for emphasis, hit play, we've got 12, we'll go back, we'll find based on ID 12, and you can see that's lowercase that as we referenced in our resolve function there. So that wraps it up. By now you should have familiarity with the basic concepts of how to put together a production grade GraphQL server. In the next video series, what I'd like to tackle is how then to take this basic premise of a GraphQL server and turn it into a Relay compliant server. And this is slightly different because Relay adds a few extra different field types and query types that we want to be able to perform. So we're going to have to look at that in a later video series. In the meantime, If you require any code assistance and you're working on GraphQL or any related Node concept, you can usually find me on Code Mentor. I have a link in the description of this video. Please do subscribe to this channel if these types of topics is your thing, and if you're interested in working with me on a future project idea, I may be open to some future freelance work, so please do get in touch with using the contact details beneath this video. Hope you've enjoyed it. I'll speak to you again soon.